Today's lesson is lesson 5. As we work through these lessons, we look at them both from the student perspective as well as from the teacher perspective. So there'll be times where you are going to be the student and I'm going to walk you through how this lesson, the content of this lesson and how I would teach this lesson. And then sometimes I'll talk to you and give you teacher tips along the way of how to teach and facilitate this lesson to your learners or to your children if you are a parent. So each lesson is in the lesson plan, provides you with all the information you need on the at the beginning of the lesson to know what this lesson is about. Last week in lesson 4, or on Tuesday in lesson 4, we looked at making Panda walk in place. We looked at 2D animation and how we can use costumes in InBlock to give the appearance of an animation effect taking place. And so we used 2 different costumes to make Panda's appearance with the Panda's legs move back and forth. And Panda hadn't yet moved across the screen. Panda was just walking in place because we gave this animation effect using the costumes. We're going to continue with that in today's lesson, where we're going to actually take the animation and we're going to have Panda move while Panda is walking. So Panda will have that 2D animation effect of the walk, but we're going to have Panda move forward while that happens. So in today's lesson, our objectives is to create a program in InBlock that contains multiple sprites. This will be our first program where we add additional sprites to it. We'll use the motion blocks in InBlock to control the motion and the position. We're going to position using X and Y coordinates, so we'll have a math connection in this lesson, as well as explaining the importance of setting a position at the start of the program. We're going to use multiple sprites in this that are running separate programs. We're going to see that each sprite in an InBlock program can have its own sequence of actions happening, and they can happen simultaneously. We're going to utilize the coordinate plane and the XY positions to move and to position those sprites. And we're going to combine the costume changes that we learned in lesson 4 with motion blocks to animate a sprite walking across our stage. And we're going to look at how different values impact the blocks that we're using today. So in the past, like last lesson, we looked at how if we changed the value in the wait block, it caused us to wait a shorter or longer amount of time. We're going to explore how values in this lesson are going to make the speed of our motion slow down and speed up. So those are the basics of what we're going to do in today's lesson. Again, you need to have InBlock either installed on your computer to follow along, or you can use the website, the web app version of InBlock. Either one is perfectly fine for today's lesson. Just go ahead and have access to InBlock in order to follow along as we continue. We do provide the CSTA and IST standards. I do not go over them in the videos, but they're there for you to review as you look at these lessons. Each lesson begins with a warm-up, which reviews the prior lesson. So as a review, we're going to look at what we did in the last lesson. At this point in time, I'm going to switch over to the slides. Those of you who have these files, you can follow along with the lesson plan as well. But since I'm going to be teaching this to you, I'm going to put my teacher hat on and I'm going to head over to the PowerPoint slides and show this from the slides. As a reminder, the slides have the student-facing content. It does not have the behind-the-scenes teaching tips included in them. So if you're doing this at home or you're using this with your distance learning, the slides are definitely something to show or give to the students. I would not give the lesson plan to the students because the lesson plan provides the answer keys and the solutions as well. So as a review from lesson 4, we looked at this block or this program, this set of blocks last time, and this is where we left off. We ended our lesson with when the space key is pressed, forever repeat, switch to the next costume, wait half a second, and then repeat that again. And so that will happen forever. At our last lesson, we looked at some blocks and we explained what these blocks do. It was our first time seeing the forever block. And as a reminder, forever is a loop. Another loop that we learned last week was the repeat loop, And the forever block is going to continuously repeat whatever blocks are nested inside of it. We also added to our programming library the next costume block. If somebody wants to throw in the chat, what block category does next costume belong to? What category does it belong to? We've looked at a lot of purple blocks and they all fall into the same category because remember, blocks in InBlock are color coded. But next costume works when a sprite has multiple costumes, and it allows us to switch to whatever the next costume is that's in the costumes interface. In the last lesson, we also looked at the costume interface for the first time, and we were able to see costumes that were already included with a sprite that was in InBlock. And then we, to go through the chat box real quick, I see that some of you are saying that it's in the looks category, which is correct. The next costume is a looks block. And we've looked at many looks blocks, some of which were the say, we looked at the effects, and now we looked at costume. Also, we looked at a control block, and that was the wait 1 second, and that allows us to pause the program and wait the specified amount of time. So it allows us to add a delay into our program, which is a great tool that we used, and we used that in the last lesson to slow down how quickly Panda looked or appeared to be running in place. Because without the wait block, Panda was running very fast. So we've now helped Panda walk in place. Remember, Panda didn't know how to walk, so we taught Panda how to walk in place. But now Panda does not know how to run or move forward. So Panda has decided to enter an upcoming race, and we need to teach Panda how to move forward. So we're going to help Panda compete in this race. So we're going to add to our programming knowledge in order to help Panda race and help Panda run. Okay? The blocks that we're going to add are going to be in the motion block area, And the block that we're going to use is the move 10 steps. Now, we used this block very briefly in lesson 1, but we're going to use it and understand it quite a bit more in this lesson. Before we just put it into the script area just to see what happens in InBlock. But now we're going to combine it with everything we've learned to have Panda run or move. So as a reminder, we observed in lesson 1 that the move 10 steps block moves the sprite 10 steps to the right or in the direction that the sprite is facing. The distance can be changed. So we're going to use this to control how our Panda moves. Now, I have a question for you. This example on the right-hand side does not say move 10 steps. It says move 1 step. Okay, in the chat box, predict how the sprite will move when the value is increased or decreased. So, which of those, the move 10 steps or the move 1 steps, would be slower? Which one would be slower? Move 10 steps or move 1 step? You can go ahead and put that in the chat box. Which of these, move 10 or move 1, would be slower? Definitely, move 1 is the answer that many of you are providing, which is correct. The smaller number of steps or the lower number, as we decrease the number or the value in that move block, our sprite will appear to move slower across the screen. So we're going to go ahead and make this example. we're going to make this example. And as a reminder, the PowerPoint slides do give instruction on how to do this. I'm going to head over to InBlock and I'm going to teach this to you so that you can see the instruction and follow along in InBlock. We'll return to the slides when we're done with these steps. So at this time, we'll move into InBlock. And when we're in InBlock, we're going to make a new file. If you had a file open, you'll want to close the file that you had open, so that we're looking at the new file page. We have a new file in InBlock. As a reminder, when we begin a new file, we begin on the Devices tab. We're going to move over to the Sprites tab because Panda is a sprite in our document. It's not a device. And we're going to go ahead and build out that example code that we saw. If you've been following along with these lessons as we go along, you should be able to, based on the colors of these blocks, find these blocks. So I would ask that you go ahead and build your code. As you can see on my screen, we're going to find and select the appropriate blocks from the block area to put when the green flag is clicked, repeat forever, the forever loop. And inside of that forever loop, we're going to add that new block that I just talked to you about. That new block is the Move 10 Steps block. It is in the blue motion category of our block library or our block area. And then we're going to combine that with our next costume block that we learned last lesson. So we have a basic program here. We are going to change this down to one step like our example instructed us and the instructions in the lesson plan tell us. So when the green flag is clicked, forever repeat, move one step, next costume. Now, I talked in the last lesson about the importance of having your students read the code and read the blocks as they show on the screen, because sometimes they will think they told it to do something, but they might have left out a portion. So having them read from top to bottom can be very, very helpful. And so as a teacher or as a parent, as you're instructing your learner, you're going to want to read your code as well and get in the practice of reading that to them. So to run our program, we hit the green flag. I'm going to bring mine a little bit bigger so you can see it. And when we press the green flag, we should be able to run this program. It's going to run forever. As a reminder, it will not stop until I tell it to stop. Okay, because a forever block will run forever. We learned in the last lesson that this glowing yellow border around a section of our code means that that code is running. I'm going to go ahead and hit the stop. So I would like for you in the chat box to tell me or describe where on the stage Panda is located after the program runs for a little while. Where is Panda located right now? I've ran the program. I've let Panda move forward. In the chat box, go ahead and describe what problem, where is Panda located and what problem do you see? I'm going to run this again, and you can do that as well. You can run your program again. You can stop, run again, stop. There's a problem here. I see a problem. Can someone describe in the chat box the problem that we see? Okay, Panda is on the extreme right or the far right of our screen. Panda's off the screen. Somebody suggested that we drag Panda back, which is an option, but I'm going to teach you something different in this lesson. But we did learn in previous lessons that we can click and drag Panda to a new position. But that doesn't solve the problem forever, because every time I run this program, Panda is still going to get stuck on the edge of the screen. Okay, so he walks to the right and gets stuck off the edge. Okay, so what we're going to do is we're going to solve this problem. Great observations, everybody. Great observations. So we're going to learn in this lesson how we can position a sprite using some blocks from our block area from our library instead of manually having the user drag Panda every time. So we don't want to have the user drag Panda. As the programmer of a program, we get to be in control, and we get to control Panda through the programming blocks that we add to our program. So we found that Panda got stuck or ran to the right edge of the screen, but appears to get stuck there. Okay? Panda will remain in the same location at the end of the program when we try to run the program again, because Panda's position has not been set in our program. We have not anywhere in this program given a position for Panda. So we're going to have Panda start on the left side of the screen. We're going to make Panda start on the left side of the screen when we click the green flag. We can use, I'm going to go back to our slides to show this to you. We can use, here's an example, it's in the slides, we've watched it on the screen, but we can use this new block, the go to XY coordinates block, in order to modify our program, which you can see in the example, to give Panda a starting position on the left side of the screen. Every single time we press the green flag, Panda will move over to the left side of the screen before moving forward. That's a really awesome tool that we can use to control our program better. Okay? In the block area, we will head over, well, the function of this, real quick, the function of this is to set that specific position, and we're going to use X and Y coordinates to do so, and we have a horizontal and vertical plane for these in X and Y coordinates. Okay, so let's take a moment to look at our X and Y coordinates of our stage in InBlock. In InBlock, we have an X-axis, which is our horizontal axis. It's the blue line on this image. And then we have a Y-axis, which is the vertical axis, and it's the red line on this image. Okay, the minimum value for X is negative 240, and the maximum value is positive 240. There is an orange dot in the center of this axis in this diagram, and that is X0, Y0. X0, Y0 is center on your stage, and everything to the left of that is negative, and everything to the right is positive. When we're looking at the y-axis, our minimum or lowest value is negative 180, and the highest or maximum value is positive 180. So everything above that orange circle is positive, and everything below that orange circle is negative. This is the way the X and Y coordinates work in InBlock. So, if your students don't have familiarity with X and Y coordinates, there is a feature in InBlock that's going to help them determine what those X and Y coordinates are, and I will show those to you in a moment. But in the chat box, where could we put Panda if I wanted Panda to start over here on the left side of my screen? I'm going to go back to InBlock. If I wanted Panda to start over on the left side of the screen, okay, over here somewhere, what would be a good estimate for X and Y coordinates? Take a guess. Take a guess of what could we put, looking at our coordinate plane here in our diagram, what X value and Y value could we use to position Panda on the left side of our screen? Everyone will have a slightly different answer to this question, and that's okay. That's okay. So we have some of you saying that the X should be 0 and the Y could be negative 240. Many of you are saying that same thing. That's a great position. We could do negative 240 to negative 250. Someone's saying we can have him partially off the screen. You can go a little bit off. Flavio is saying negative 191 and negative 85. That's great. That would put Panda down a little bit below the middle of the vertical axis. Great answers, very good answers. So let's go ahead and let me show you what I was talking about that shortcut that InBlock provides. When you are in InBlock and you move your Panda around, when you move Panda around, click and drag, you will notice in your Sprites tab that there are X and Y fields right here that give us the coordinates of where Panda is. So every time you move Panda on your stage, those X and Y coordinates will change. So we can move Panda off to the side and get a value there, okay? When we are in our motion blocks and we go and we find the X and Y coordinate, the go-to XY block, when we move Panda around on the screen, those X and Y coordinates will also change in that block. So go ahead and put Panda somewhere on the left side where you want Panda to be, and then you can drag the go-to XY block over and put it between our when green flag is clicked and our forever block. It should be above the forever block, and it will be the coordinates that Panda will begin at when we run our program. Every time we run our program and we start it over, Panda will begin at that XY coordinate. So I'm going to stop and run my program again, and you will notice Panda begins at the left part of the stage when we run our program again. So now that we have looked at moving Panda forward, Panda's now moving forward, and it was as simple as using the move steps block inside of a loop. And we have positioned Panda with a starting position on the left side of the screen. We're now going to continue to build out this story. Panda is entering a race, and Panda's friends have come to cheer Panda along while Panda races in the race. We're going to add a background. We've learned how to add a background previously, so we're going to go to the background tab. We're going to click the plus sign, and the background that we're going to add is the playground background. As a reminder, there is a search box where you can search for the background that you would like to add. We're going to add the background playground because you can see the race goes along the track goes along the field. Now my Panda's a little too high, so I'm going to reduce my Y position to about a negative, let's try negative 80. I'm going to do negative 95 to get Panda running on the racetrack and not on my grass. Okay, so I reduced my Y to bring Panda a little bit lower. Okay. We're also going to, now that we've added a background, we're going to continue to set our scene, and we're going to add another sprite. We've not done this before. So in order to add another sprite, we're going to come back to our Sprites tab, and you will see the plus add icon in our Sprites area. And when we click the add icon, we get the sprite library, and we're going to search for Boy 11. Boy 11. Boy 11 is one of Panda's friends. And we can move Boy 11 to the sidelines in the grass wherever you want Panda 11 to be. Boy 11 to be. And we are going to program this friend to cheer for Panda. And I'm going to head back to the slides. And as a reminder, all of these instructions are in the slides. What we would like to do is we'd like to build this program. We're going to find and select the appropriate blocks from the block area to create this program. When the green flag is clicked, we're going to use a forever loop, and boy 11 is going to cheer for 0.5 seconds, wait 0.5 seconds, and then that will repeat continuously. That will repeat continuously. Heading back to InBlock, we know now where to find those blocks because we've been working through these lessons, and we're going to, when the green flag is clicked, forever say, cheer for 0.5 seconds, and wait. If you did not have time to build that one out, that's okay. You can just watch on my screen to see how it works, and then you can come back to it later. Since that's a review from a previous lesson, I want us to continue on. So you can see that boy 11 is cheering for Panda. Okay. Now, when we add a sprite to InBlock, how do we know whether or not a sprite has multiple costumes? And this is in the lesson plan. In the lesson plan, as a reminder, there are some timeout pieces of the lesson plan that are behind the scenes. These are not in the PowerPoint, but these are there for you as a teacher to have some additional understanding of how InBlock works. So when we are adding a sprite to our library, to our program, reminder, you can come here and look at costumes, and we can see that boy 11 only has one costume. If I were to add a sprite, and I'm going to search for boy, and when I'm searching for boy 15 has a little icon right here in the top left corner, and when I hover over boy 15 moves. Do you see that? It animates. That is because boy 15 has multiple costumes. But boy 11 does not. There's no icon in the top left corner, and boy 11 does not animate when I hover over it. That's an important tip for when students are selecting sprites to add. When you hover over sprites, if they have multiple costumes, they'll have that icon next to them, and they will animate when you hover over them. Okay, and so you can begin to look, and you can see when you're looking for a sprite that has multiple costumes. And I'm not finding, these ones don't, but you can see when you work through which ones do. Okay, so the independent practice of this lesson has students add boy 15 to this project. Another tip is I'm going to run my program, and I want you to identify a problem. And we're going to see that problem right now. Do you see that Panda is running behind? Panda is running behind my other sprite. So how do I change the order of my sprites? That's another question here. How do I change the order of my sprites on the stage? Okay, in order to change the order, the last sprite to be moved will become the top layer. So right now, the last sprite that I moved my boy down into the grass. Well, if I click and drag on Panda, Panda will now come on top. If I drag boy, boy is on top. If I drag Panda, Panda is on top. So I just need to drag Panda to put Panda back on top. And now when I play my program, Panda is in front of the other sprites. So in this lesson, we looked at having Panda race. We looked at putting Panda motion and movement along with that animation we learned in lesson 4. We looked at the importance of setting a starting position at the beginning of our program being run so that our program can reset. We can press the green flag and Panda will start at the left side of the screen. We looked at how we can add another sprite to our program. We looked at adding another sprite to our program, and that sprite that we added was boy 11. And as a reminder, the slides walk through all of those steps as well, so you can provide those to the students. Here's an example of what their program will look like. This is when we get into the independent practice lesson part of the lesson. As we work through the lessons, each lesson has a guided practice for you as the parent or the teacher to work with your learners on. And then there's an independent practice portion of the lesson where students are given challenges and are given just requirements of that challenge to be able to showcase the learning that they had in this lesson. And so in this example, the students are being tasked with creating a project by adding another sprite to their project. So they're going to include boy 15, who is going to also cheer on Panda when the green flag is clicked. And then they're going to have boy 15 change costumes while cheering for Panda. Panda is going to move across the stage when the green flag is clicked, and Panda is programmed to start at the left side of the stage when the green flag is clicked. As a reminder, each lesson also has an extension, and the extension is for students that have remaining time, or if you want to challenge some students or all students with additional challenges, we can add a third friend for cheering on Panda. We can have Panda say something at the beginning before starting to move forward. We can trigger the start of the race using the space key instead of Panda starting to move at the very beginning of the green flag being clicked. We can change the appearance of boy 11 or even one of the other sprites we've added to using the transformations that we learned in lesson 3. And so there's added challenges here for your learners to be able to continue to add functionality to this program. As a reminder, the lesson plan does also in the independent practice give you as the teacher some of the information that can be helpful. So here's the code that would be used for boy 15. And we can go ahead and try this out together. We can go ahead and add another sprite so we can practice it one more time, and then that way you will have worked through the independent practice as well. We're going to add another sprite, and as a reminder to do that, we're going to be on the Sprites tab. We're going to click the Add icon, and we're going to search for boy 15. We're going to position boy 15 where we want him to be. And there's going to be a problem. I'm going to run my program, and right away I see a problem. What problem do I have? In the chat box, what problem did I just make? Something is wrong with my program. So I'm getting the recommendation in the chat box that I need to put Panda on top. How do I put Panda on top again? I'm not sure I remember how to do that. How do I make Panda go in front of boy 15? Because right now Panda appears to be running behind boy 15, which is makes it look like boy 15 is standing on top of Panda. So how do I fix that? Okay, I can click on or drag Panda. So if Panda is the last thing I click on or the last thing I move, now Panda will be on top. Pretty simple solution. Thank you all for your assistance and reminding me. Sorry, I forgot. And now we're going to program boy 15. We're going to program boy 15. We're going to have boy 15 be triggered by the when the green flag is clicked event. We're going to have boy 15 repeat the cheering forever because boy 15 wants to cheer like a good friend and cheer over and over and over again. We're going to use the say block. We're going to use the say block. And then we're going to use the wait block in order to control that timing. And you can change this timing to however you want it to be. That is your choice. When you are working in InBlock. Okay, and so now Panda's friends are cheering Panda on as Panda is racing across the racetrack. Okay, as a reminder, there are a few ways to save a project when you're working. So you can, if you are logged into an online account, which we have discussed in previous lessons, you can save your, you can go to File, you can change the title at the top first, which we'll call this Panda's Race. Okay, and we can save it. And if I were to save this right now because I am logged in, it is going to save it to my online cloud account. If you are not logged in, that will not be the case. But mine saved to my projects folder on my profile on my online account. It has not been published, so it is not visible to the world, but it is saved online. I can access it on multiple devices. If you would like to save to your computer, as a reminder, File, Save to your computer will allow you to save this on your computer if you would like to save it there. I'm going to come back to this file in a moment, but I want to go back to the lesson plan to close out the lesson plan. I'm going to teach you a little bit today about Google Classroom and how InBlock integrates very seamlessly with Google Classroom. So we're going to use that file as an example in a moment to do that. But for now, I wanted to go back to the lesson plan and to remind you that the lesson plans close out with a wrap up. And in this case, the wrap up that is suggested is to have that sharing out again where your student projects are on display. And we've gone over this in lesson 2, I believe it was, where we had students communicate and collaborate around the projects by sharing something they found interesting and something they suggest improving on each other's projects. As a reminder, it's very important to encourage this type of communication early on in your lessons and in your instruction so that your students can get practice doing this and can build up to having more complex conversations as you continue to do projects in InBlock and in your curriculum. They can, when you get to bigger and harder projects, they have had practice having this type of feedback and receiving this type of feedback. And feedback is an important part of building programs because the programmer programs their project or their program for a user, not for themselves. So getting feedback from your users is an important thing to incorporate into your classroom. We'll head back to the slides. And we're going to close out with the review questions at the end of the lesson. And as a reminder, every lesson has 3 to 4 review questions at the end of it. So which category did we find the Move 10 Steps block? Which category did we find this block in? Motion, D, great answer. Okay, motion D. It is in the motion category. Which of the following blocks allow us to position a sprite on the stage using the specific coordinates? Which one of these blocks did we use today to control the position of our sprite, the position of our sprite? I see many of you are answering B, which is correct. Now, this was the positioning with specific XY coordinates. You can see that there are in options C and D, those both refer to positions. However, those were not specific coordinates. And we have not learned those blocks yet. Okay? And which of these programs has the sprite running the fastest? Which of these programs would have the sprite running the fastest? Now, there are two different parts of these programs that are controlling speed. So this one's a pretty complex question. Which of these would be the fastest? And we will look at the answer as to why. See a few different answers. The consensus appears to be B, and we're going to explain why B is the correct answer. Why B is the correct answer. Okay, programs C and programs D both have a wait 0.5 seconds inside of the loop. So even though this one moves 50 steps and this one moves 10 steps, they have a wait 0.5 seconds between taking each step. Okay, so this one would move 50 steps. Option C would move 50 steps, wait half a second, move 50 steps, wait half a second, move 50 steps, wait half a second. Okay, options A and options B do not have that wait block, so therefore they're not being slowed down by that delay or that pause in the program. So option B would be the correct answer because option B has it moving 50 steps, moving 50 steps, moving 50 steps, moving 50 steps without a wait in between taking each, performing each step. Something to think about there is that the wait and the move blocks are what controlled the speed. Now we have a little bit of time, which was purposeful. I want to go through one more feature available to you with InBlock and using it in with education with your students. And this can be very helpful for any of you instructors that are doing distance learning and working from home and are using Google Classroom as a tool to facilitate your learning in this virtual space. So InBlock has integration built in to work with Google Classroom. And when you are working in InBlock, I'm going to open up a sample program from today's lesson, lesson 5. I'm going to open up example 1. Example 1 is a file that we worked with at the beginning. This was the first thing we did. And I'm going to drag these blocks and separate them out. Okay? I'm going to separate the blocks and move them around, and I'm going to have them not connected. Okay? Some of you may decide that you want to provide students with starter files so that they're not completely working from scratch. So what we can do is we can make this file. It has the blocks that they're going to need, but we're going to have them have this file. We can give it to them via Google Classroom. They can take this file and use it to begin the lesson. Okay? And so what we're going to do is we're going to go to File, Share To. Well, first and foremost, make sure that your file name is what you want it to be, because that's the file name that will come through Google Classroom. We're going to go to File, Share To, and then when you go to File, Share To, it's going to first save your file so you have it saved. And then it's going to allow you to share to Google Classroom, and you will click on Share Project to Google Classroom. Okay? And when you do that, it will go ahead and launch Google Classroom. If you are already logged into Google Classroom, which I am, and I already have a class created for this class, so you need to have your Google Classroom already set up. I'm going to choose the class that I want to send this file to, and you have choices. You can create an assignment, you can ask a question, you can make an announcement, or you can create material. And so when you would use these, this is a starter file for an assignment, okay? But maybe you want to give a project that's broken. Maybe you want to give a project that has problems. Maybe you want to ask a question. Maybe you want students, maybe you want to say to your learners, what's wrong with this project? That's asking a question. Or maybe you want to say to your learners, open this project, like in lesson 1, where we had them open the project and play the Space Adventures game, and our question was to them, describe how this game functions. That's asking a question. So you can ask a question and have your students answer right into Google Classroom. So a lot of these lessons have those questions built into the lessons, and you can be assigning those in Google Classroom. But in this case, I'm going to create an assignment. I'm going to click go, and now I'm back to my normal Google Classroom environment. If you use Google Classroom, this screen should be familiar to you, and I'm going to say, using this starter file, you know, move the blocks to the correct sequence to make Panda walk across the stream. Okay, and then I can assign this and I can put points to it and all due date and all of that, like you're familiar with. And when you assign this to your classroom, it will confirm that that has happened. And when you view your classroom, you will see that assignment has been posted. You can view your students, but I can also go and view it as though the student would. When you do this, what this does is it provides a link to the web-based InBlock app, where when they click on it, a student clicks on it, and they go into the InBlock IDE. If they have an online account, they'll be logged in. If not, they won't be. And they will be able to edit this program. Now, right now, because this program is owned by me, I can edit it and it will change the original file. So I'm going to sign out and show you what this looks like if a student were to open it. If a student opens this file and they are not logged in, when they go and edit the file, it does not say save and publish at the top because they do not own it, okay? But they can edit the program, and then once they edit it, they can save it to their computer, or they can log into their own account and save this file into their account. And now they'll have a copy of it in their account. They can also download it, save it to their computer, and open it in the installed version of the program if you have the installed version and you'd prefer for them to work there instead of in the web-based version. But that is the integration that is available in Google Classroom, where you can easily assign and send InBlock files out to your students. So that's a part of the features of InBlock that we wanted to make sure we showcased. So at this time, that is my conclusion of lesson 5. As we move forward, we're going to continue to work with Panda. We're going to be doing some really neat things where we begin to interact with Panda. We're going to look at more user controls. We're going to look at how we can change the backdrop in the middle of a program, just like we change costumes. We have a lot of really exciting things to move forward with. I would like to, before we conclude, to remind you that we have a feedback survey that we have been using throughout in order to obtain feedback from you all. So if you have any feedback from today's session, please go ahead and share that feedback with us. And we will open up the floor to questions and answers. I know that there is one question that was asked that we have not covered, which was, how do you control the overlapping of the word bubbles? So actually, let me show you that in InBlock. Okay, let me open my project from my account that I had multiple people talking. And you will see that if your characters are really close together, that your word bubbles will overlap, okay? We will also see that if your panda is in front, but, oh, hold on, let me move him lower. If your panda is in front, but when a word bubble appears, the word bubble goes on top of Panda. There is not a way in InBlock to control the word bubbles because how they stack, because the word bubbles are the last thing to appear. So when they appear, they're going to always stack on top. So they're going to be in the front. they're going to always be in the front. So my best advice for that is to position your characters so that the word bubbles aren't overlapping anything crucial. So right now they're off to the side, they're not overlapping anything crucial. There's not a way to have a word bubble show up behind another sprite. And I hope that answers that question. So I'm going to go ahead and stop sharing. I'm actually not using the Google Classroom feature as part of this this series. So we're not adding participants into the Google Classroom. But if you want to share your work, as a reminder, and I will provide the link to that, one really great way to interact with the learners is through the studio that makeblock has created. Please share your work and your files to this link. The link that I've given in the chat box will take you to, oops, sorry, let me send it to all panelists, I apologize. I mean, all panelists and attendees, apologize. Get that to the right person, sorry. Let me send that in the chat. There is how you get to the, ability to share your work, and to show you again what that looks like. This is the avenue that we are using to share projects made during these lessons. So if you have created any projects that you want to share, you can add those projects. I will actually go ahead and go to my profile and I will share one for you. Oh, I signed myself out. I'll put my project in later, but you can add your projects into this by clicking on add a project, and this studio will let you contribute your project. So keep in mind that you can contribute your work there.
Question for you. There was a question that came through about using the web-based version versus the install. And are there any other benefits or drawbacks to either one of them other than just having the software available offline?
Right. The offline feature, as well as if you're using this in the classroom at a school, which I know none of us are at schools right now, but a bandwidth issue, if you have all of your students online in InBlock, some schools don't have the internet bandwidth or capacity to handle that, and so they ask that their schools, that the school district will ask that the teachers use the installed version because it's less demand on the school's network. But both features allow you to control both devices as well as your sprites. When we get into programming hardware, so if you're using InBlock with hardware, with makeblock hardware, like the MBot robots or the MTinies, or you are programming the Halo code or just different makeblock devices, the hardware, robots and devices, you will, if you are on a, you will also need to install the drivers for those, especially if you're using the web app, because the web app does require those to be installed. But for what we're doing with these lessons, both work perfectly fine. There's
Okay.
no features that are missing in the web app. The web app has all the same ability to edit. It's not like a device on like the that sometimes where on a phone it's different. The web app has the same functionality.
Okay. And as far as like logging into accounts from home or at school, they can do that in the web app or in a download. Okay.
You can be logged in both. I'm usually logged in both.